Okay, so let's continue with our next video in our coding exercise series. So in this video, we will solve the LeetCode problem 468 validate IP address, and this is a medium category problem. Okay, so let's read the question. So given a string query IP, so you have uh, a function, or maybe you can say you need to write a function where the user will give the string, right, query IP, and you need to return IPv4 if the particular string is a valid IPv4 address, or you need to return IPv6 if the particular string is valid IPv6 address, or neither if whether the query IP is not IPv4 or IPv6, right? So basically what we need to do, so if query IP is, let's suppose, 0.0.0.0, so this is a valid, right? This is a valid uh, IPv4 address, right? So if someone will enter or call this function using this string, then we will return IPv4 as a string, right? If query in the query IP, if someone will enter IPv6 address, so v6 address consists of 8 uh, parts. So let me copy paste this. So let's suppose if someone enter this one, then this is a valid IPv6. So what we need to return, IPv6. If someone will enter, let's suppose, uh, 12345 6 dot 123 dot this dot this, then this is not a valid IPv4, not a valid IPv6. So we are going to return a neither, right? Okay. So by looking at this question, immediately what should come into our mind, right? We should be like, okay, let's read further more question. A valid IPv4 address. So first we should know how the IPv4 address looks like, how the IPv6 address look like. So they said IPv4 address consists of four parts. We know, like, IPv4 address is generally consists of four part, and each part is separated by a dot, and each part consists of digits from 0 to 255, right? And like this one, and but uh, there should not be a leading zero, so this is wrong. So 192.168.01 is wrong, so it can be one. Similarly, here is a leading zero, it is wrong, so these are invalid. Similarly, if we have some special character add there, this is also invalid. Similarly, IPv6 8 parts, but each part separated by a colon, so this time it's not separated by a dot, it's separated by a colon. And each part, the length of each part can be from 1 to 4, it is mentioned in the question. And this x can be of digits means 0 to 9, can be of lowercase, a to f can be of uppercase. Like, leading zeros are allowed, so in this leading zeros are allowed, but in this leading zeros are not allowed. Okay. So how we are going to solve this question? So immediately I feel like, uh, even like, how you are going to solve this problem. So we need to create a pattern. So we are going to use a regular expression. So we have a inbuilt module in the Python RE, that is a regular expression. All right. Doesn't matter whether you know the regular expression or not. We are going to solve this problem uh, very in, like, in a detailed way. All right. Okay. So now if we have to write some regular expression, right, and we need to write some regular expression for IPv4, and we have to write the regular expression for the IPv6, right? So let's say you are going to write the regular expression for IPv4 pattern. Let me put none, and you are going to write the regular expression for the IPv6 pattern. So let's suppose you have write that. I have not written, but let's suppose you have write that. What next? Then within the regular expression module, there should be some function because you need to match, because whatever the query string we are providing, whether if that matches with the IPv4 pattern, which means it's IPv4 address. If that matches with the IPv6 pattern, which means this is IPv6 address. If it is not matching with the IPv4, not matching with the IPv6, it means it is neither. So something you need to use if elif condition, right? So if regular expression match with, right? Now match, what we need to match? IPv4 pattern, right? So IPv4 pattern, with which string you need to match? Query IP. If it is matches, what we need to return? IPv4, right? Elif re dot match. If it is matches with the, sorry, IPv6 pattern, query IP. If it is matches with that, we need to return IPv6, right? Else we will return neither. Okay, so this code will remain as is, right? Okay, now if you go to the regular expression documentation, and if I search for match, right, I could found there are two things, two functions. One is a match, which take a pattern and which take a string, and it is going to return if it is matching, and otherwise it is going to return none. All right. Similarly, we have a full match. So what is match? What is full match? And because this looks like both looks like same only. So shall we use match or shall we use full match? So we can use either of them. We will try both, but as of now, just focus on the match one, right? Okay. But make sure like you have the two options. One is match, one is full match. All right. There is a little difference. We will cover that. Okay, so this is done. Now the only part left is you need to create a regular expression. Okay, now if you closely noticed, they have mentioned x1, x2, x3, x4, and x, whether it's x1, whether it's x2, whether it's x3, whether it's x4, whatever the regular expression of x1, that regular expression of x2, that should be the regular expression for x3, that should be the regular expression for x4. Which means if you just create a regular expression for x1, then we are just going to concatenate basically four times. As an example, if I able to create IPv4 octet, let's suppose I have created a regular expression for the first string. Let's suppose this is a regular expression for the first string. First string is this part, x1. Let's suppose you have created that, right? We are assuming as of now, right? Because we are trying to solve this in a step by step. Then, but this is a regular expression for the first part, right? I We just need to repeat it four times, right? So what I can say is, let's suppose IPv6, sorry, IPv4 pattern is equal to, I just need to, because this is a regular expression is basically string, I just need to concatenate. I need to write four times, right? I need to write them four times. But there is a dot in between. There is a dot in between, which means I need to concatenate with the dot, right? I need to concatenate with the dot. This is still wrong, but we are going to learn. So we are going to concatenate. So okay, and once we concatenate, our regular expression will be ready. We are just going to put it here. Okay, this is still wrong, but you have some like a wider picture in the mind, uh, what we are going to achieve. If we just write for the expression for the first part, you just need to repeat it 1 2 3 4 times and concatenate with the dot. Similarly, if you able to write the regular expression for the IPv6 first part, IPv6 octet. Let's suppose this is a first part, first part, right? Then what will be the regular expression for the IPv6? IPv6 pattern. I just need to repeat it 6 times, right? I need to, sorry, I need to repeat it 6 times, but I need to concatenate with the colon because IPv6 concatenate the colon. Now plus, so first, second, and after the second again colon plus. So this is a very simple way we are first covering. Was first thing is, let's solve the question plus this. So 1 2 3 4 plus, so 1 2 3 4 5, so plus colon 6 plus colon 7 plus colon 8. So we have written 8 times. So let's verify it. Let me expand this. So 1 2 3 4 5 6 7 and 8. Right. Okay, we have done that. Okay, so now the main part is we need to write this regular expression. So let's try to write the IPv6 because IPv6 is a little bit, even both are easy, right? Okay, whenever you write any regular expression, whenever you write regular expression, you need to put R in front of that, and under the R, you have to write a regular expression. It is not mandatory you have to put the R, but just make a rule so that you should not remember when should you need to put a R or when you should not put a R. So R is a row string. R means a row string. So always and always, irrespective of any regular pattern you are going to write, just put R and then write whatever your regular expression, right? Because this is a row string. Okay. And why we generally put R, we are going to cover, but just make an habit. Even you have to regular expression for just A, still put R. Even if a regular expression A, I don't need to put R, but still put R, right? So that you don't need to remember when you need to put R, when you don't need to put R. Okay, so always put R. Okay, now, so IPv6 address consists of digits. So when I say it consists of, so basically we are creating a regular expression of the first part. So first part only, right? X1, because whatever the first part, you are just need to repeat it 7 more times, right? And concatenate the column. Okay. So the first part or any part you can say consists of digits. So digits means 0 to 9. Okay, 0 to 9. Okay. It consists of letter, small letter A to F. So it consists of letter small A to F. It consists of uppercase letter A to F. It consists of uppercase letter A to F. So now the question is, why should I write this? Why should I put this square bracket? So whenever you put square bracket, and within the square bracket, whatever you write, which means any of this character, any of this character. So the first letter can be either 0, first letter can be either, because the first letter can be of length 1 as well, right? And it can be of length 4 as well. So I am not considering the length as of now. I have just covered what can be the first letter consist of. First letter consists of the digits, first letter consists of the English alphabet A to F, first letter consists of the A to F. So it could be any within the square bracket, means any one, not all or not a group, any one, either 0 to 9, either A to F, or either capital A to capital F. Okay, now, so if you just write this, this is going to work only for few cases where you have like 0 colon 0 colon 0 colon 0 colon 0 colon basically 8 times, right? Because it's only one digit, or maybe 1 colon 1 colon 1 colon 1 colon 1 8 times, right? Because you are putting one like only one character. But they said this length, the first, this is the first letter or first digit length can be of 1 or can be of 4, so it can be very still 1 to 4. So you just need to put bracket, so it can be of length 1 to 4. That's it. So now we have covered a regular expression where uh, it contains 0 to 9a, a to f, a to f, and this length can be of 1 to 4. And our IPv6 regular expression is ready, right? Okay, so now we need to create a regular expression for the IPv4. So let's do that. Let's do that. So for the IPv4, we know IPv4 only consists of digits. So generally for the digits we know we put /d. But if you put /d, which means 0 to 9, right? uh, but it can be of 2 digits or it can be of 3 digit as well, because they said it can be of 0 to 255. So where they have mentioned 0 to 255, I forget. Yeah, here. So 0 to 255. But if you just put /d, which means 0 to 9. Now if you put /d 2, so, so when I say 2 here, when I say 1 to 4, so it means length from 1 to 4. So this curly bracket says the first digit or whatever uh, the expression, it can be repeated that number of times, right? Okay, so when you say 2, which means 0 to 9, but it could be 00 or 99. So right, so 00 to 99, but we need till 255. So neither you can use /d, neither you can use this. If you put d/3, so which means 000 to 999, this is very higher range. We just need till 255. So which means neither I can use this one, neither I can use this one, neither I can use this one. Then how should I create a regular expression, right? Because this is only numbers, right? If this is a numbers, either I need to hard code, or either I need to use /d, or either I need to use the mixture of numbers or /d, right? So what we are going to do is we are going to divide means like we know uh, the first part. So let's suppose it's still 255. So 250 to 255, because we are just focusing on the first bit, because whatever the first bit, the remaining 3 bit will be the remain same. So you could see the remaining 3 bit is the remain same. So we are focusing on the first bit. So the first bit can be between the range 250 to 255. So how you are going to write it? It is 25 is common. You can see 25 is common. And what will be the third digit? Third digit will be between 0 to 5. So this is first regular expression. So first digit, so basically first digit between 0 to 255. So if I have to use 0 to 255, I can't use /d, I can't use /d2, I can't use /d3, because if I use /d, which means 0 to 9, if I use /d2, which means 00 to 99, but 00 is wrong. If I use /d3, it means 000 to 999, which is more than 255. Even 000 is wrong, right? So which means I will hard code everything. So I divided 0 to 255 in some parts. So 250 to 255. So 25 is common. The third digit is 0 to 5. And we have just covered whatever we written in a square bracket, which means any digit. So any digit between 0 to 5. So 250, 250, 251, 252, 253, 254, 255 will be covered. Okay, so first regular is like this will be covered like this, right? Okay, but we have to cover 0 to 255, but till now we have only covered 252 to 55. Okay, so now we will cover 200 to 249 because 250 is already covered. So 2 is common. 2 is common. Now 0 to 4. 0 to 4. So can you write 0 to 4? Sorry. So can you write 0 to 4? And the last digit is 0 to 9. So for 0 to 9, can we write slash d? So answer is yes. Alright, so because for 0 to 9, third digit is 0 to 9. So for 0 to 9, can we write slash d? Yes. Okay. Now, what is the next one? So here, 100 to 199. So 1 is common. Now 00 to 99. For 00 to 99, can we use slash d? 2. So answer is yes, because 1 is common and then 00 to 99. Right, so 00 to 99 slash d2. Okay. Third is like 10 to 99. So 10 to 99 is, so 1 to 9 and 0 to 9. 0 to 9 is slash d. Okay. Now 0 to 9. How you are going to write 0 to 9? Just slash d. All right. Just slash d. Did I miss anything? 0 to 9 slash d or 10 to 99. So 1 to 9 and 0 to 9. Yeah, I think I have covered everything. Okay, so now the first digit can be any of them, right? So any of them is either this or this or this or this or this. So or means we have to just use the or operator. So let's try that. And I have told you for any expression we will write r. We will write r. Okay. So first digit can be this one, right? Or it can be this one, 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 right? And we have combined like so many digits. So just put a bracket, right? Because when you combine so many digits, just put a brackets. Okay, so now you need to combine all these 4 times, but here is a one catch, because I have told you we need to separate it by dot, but in regular expression dot means any character, but we need dot. So when you need particular thing you have to put backspace, backslash, so that it should have a special meaning. And if you have to put a backslash, because this is a regular expression, so we have to put r r. Okay. Okay, and as of now let's use the full match instead of a match. I will tell you like why we are first using full match. Okay, so let's try. Mm, we are not sure whether this will work or not, but if it is not going to work we will see. So let's try to run some test cases. Let me see. Okay, something is wrong. So they have mentioned, okay, we have forgot to put plus symbol here. All right, let me try again. Okay, I have put none here, which is wrong. Here, so you have put the IPv4 pattern. So what we will do is we will compile this pattern. We will compile this pattern. Similarly here, we are going to compile the basics pattern. Generally, we don't need the compilation, but whenever there is a complex pattern, so we prefer to compile that a huge regular expression so that we can use at any number of places. So you can say this is regex IPv4 regex, and this is regex. So now instead of pattern, we are going to use the regex. Let's try to run again. Okay, so it works. Let's try to submit. Okay, within a single run, our solution works fine. Right, our solution works fine. This is perfectly okay. It is very clear. Even if someone don't know regular expression, they can easily understand. We have not used anything complicated. Anyone can understand because it's a 4 digit. Okay, because all the 4 digit are of same part. We have just repeated 4 times, and they have separated by dot, so we have just separated by dot. But if we just put dot, which means any character, so you have to make a special meaning, which means backs like slash. Similarly here, colon doesn't have any special meaning, so you don't need to use r. But if you want to use r, you are free to use r, because as I told you, for any regular expression you are free to use r. So let me add r here. Hopefully it's still going to work, because colon is a regular expression, right? So you can still use r. Okay, I have used r, right? And then we have compiled the like pattern. Compile, by need to compile because whenever generally uh, a huge complex pattern, there is no need to compile. Even if I comment this, if I comment this, 1 second. Oops, sorry. If I comment this, I can directly use this IPv4, IPv6. Hopefully it's still going to work. Yeah, it still work, right? No need to compile. All right, this is an extra step. But why we generally compile? I will tell you. Why we generally compile? Because let's suppose this is just like a couple of lines of code. But let's suppose you have very huge uh, lines of code and being used at multiple places. So we generally compile that once, right? Store in a some regular place and use that variable anywhere, right? Okay. Now, why should I use full match? Why I will not use the match here? Okay. So here is a little catch. So full match means it should match exact thing. And in this case, you want to match the exact thing. And if I use match, that might fail, not might, that is going to be fail for couple of test cases, not for all, but for couple of test cases. Why it is going to fail? So as an example, let me show you. If regular expression is 10.10.10.10 ABC, is this is a valid IPv4? So answer is no. But if I use match, it it will consider as a like a valid IPv4, because the match will consider first part, basically this from the starting part. If from the starting, if it is going to match, it says yes, I am able to found that. So if you want to use the match, you can still use the match, but what you have to do is you have to use the starting and the dollar. You have to tell, okay, my string has the starting point this and ending at this. So as an example, let's try to use the match as well. uh, IPv4 pattern. So IPv4 pattern and R, this sorry, not this, we have to use the dollar and this one, and in between we have IPv4 IPv4 pattern. Sorry, yeah, hopefully it should work. We are saying the IPv4 pattern, whatever the pattern, it should start and end. So we have specifically mentioned start and end. So in that above example 10.10.10 ABC, that's not going to work. I'm not going to change IPv6 because we are going to figure it out if it is going to work or not. Looks it's working. Yes, it's working, right? So, oh sorry, I am not using the match. So re dot match. Yeah. So for IPv4, I use the match. For IPv6, I use the full match. If I have to use match, I have to use the like the start and the end sign as well. Because match, if you read here, if zero or more character at the beginning of the string matches, so it is not going to check the full string. It is just going to check the beginning of the string, right? But in the full match, if the whole string matches, if the whole string matches, in our case, we want to match the whole string rather than the beginning of the string. So if you just that's why like the full match is like easy. You don't need to remember shall I put this one or shall I put that one. That's why I just go with the full match. If you want to use the match, let's suppose you don't know about the match, you don't know about the full match. So if you want to use the full match, so you have to make sure you have to put the caret symbol like the beginning, because the match is going to just check the beginning of the string. At the end of the string, if it will be your name, still it is saying oh, it is a valid IPv4, which is wrong. Correct. So this is one part. But now maybe you can question, is there any other way? Because you are repeating this thing multiple times, you are repeating this multiple times. Why can't you just use some curly bracket, right? Because here when I say slash d is a regular expression, right? And if slash d is repeated two times, I just put two. So why can't I just use this one thing, IPv4 octet? And because this octet, or you can say this particular bit, is repeated two more times, so can't I just put this particular bit repeated two more times? So answer is yes, you can do that. So here just put curly bracket 2. Similarly for uh, this particular bit repeated seven more times, so you can just put okay, this is going to repeat it seven more times, right? So and then you need to combine that. This is still going to work, but for a you can say the beginner's point of view, or to make our code more readable, we are going to use that. So that's it. That's the end of the video, and thank you.